Hello, everyone. So in this video, I'm going to talk about the geometric definition of the parabola. But we need to kind of have some solid understanding of some of the definitions. Okay. So the first definition that I have is locus. So locus basically a collection of points that satisfy some rules. Okay. So we'll see what does that mean. Okay, and the parabola is the locus of the points that are equal distance from a given line and a point that is not on that line. Okay, it doesn't really look like obvious at this point, but we'll see some visual. So I hope that will make sense. And the line has a special name that's called Directrix, and the point is called focus of the parabola. So let's start with something. Let's say we have a parabola. Parabola is just graph out a quadratic equation. So let's say we have a parabola like this. And then if you have a line, okay, so let's say this line, and whenever you have a point, okay, that is not on this line, okay, which is the equal distance from the parabola, and parabola has the equal distance from that given line. So, and then I'm gonna take, let's say, this point. So the point has a distance from the parabola, maybe at this point. And if you take the distance between that point on the parabola from that line, so in my view, it doesn't look like the same, but these two guys will be equal, for us to say this curve is a parabola. So, but this is not a special point. So we do have the same relation everywhere. So if I take this point on that curve, if I find the distance between that special point and find the distance between that line, we do have the same distance as well. Not this is the same as this one, but this guy is the same as this one. So which means any point on this curve that I pick will have the same distance from that line as well as this point. And then the line right here is gonna call directrix of the parabola, and the point right here is gonna be called focus of the parabola. Okay, so again, this doesn't have to be only this way. So if you have a parabola, maybe like this, so you could have a line, maybe something like this, and the point we are going to call the focus will be somewhere inside of that curve. And whenever you pick any point, let's say this distance with this point, so this guy is going to be having same distance as this one. So the curve could be facing anyway, any direction. So facing this way or up or down or left or maybe sideways. So which doesn't really make any difference, but only thing it will be just a bit different from the others. Okay, so we will see some of those as we go. But that was just the definition. So here's the question. So if you are given a focus as -4,3, let's say this is my focus. Okay, and then if you are given the directrix is actually also given, so let's say this is my directrix, and if you are told to find the equation of the parabola with these two, we actually will try that. Okay, so let me start with this. Since my focus is given this point and directrix is on about the x-axis, maybe I should have a bit bigger picture on about that x line. So let's see something like this. Okay, so this is x and this is y, and it says y equals 5, right? So let's go ahead and draw that. And it's really important for us to kind of do the drawing, like having a picture and use the definition and just go from there, because there are some formulas, some people probably see it, search it, whatever, but that doesn't really help because you forget or you don't know which one to apply. So it's kind of challenging to deal with that. And this is my y equals 5, which is my directrix line. okay? And the focus is given -4, 3. So let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it looks like my focus will be right here. So whenever you have the focus and the directrix on the coordinate plane, it is a bit challenging to decide how that curve will be look like. Okay, so one way to determine, okay, is just find the focus, which is this point, and the directrix, and find the right in the middle. So if you look at the distance between these two, so it will be something right there. And this is one of the points that will be on the curve. At the same time, whenever you get another point, that will have the equal distance from this focus and this line. So if you take this point like this, so it looks like this point, like this distance and distance will have the same distance. And you might suspect that will be like this distance and this distance. So I hope that will make sense. But whenever you get the middle point, so you can just maybe extend like the other one. So it will be a bit easier. And when you do a little bit more practice, you will actually see immediately. So my curve will be like this. Okay, but I don't really know where this is gonna like cut through, which is I don't really care at this point. So now as soon as we have the at least some rough picture, we can make the equation by using the definition. So definition of the parabola, it says the locus of the points that are equal distance from the given line, which is this line, and the point that is not on the line. So which means if I pick any point, let's say I'm gonna take this point x comma y, and the distance between this point to that line, which is this guy, has to be same as this distance. And then this is just -4, 3. So, this point is just on this line. The x coordinates of this is also x. So I could say this is x comma 5. So what you want to do is just the distance formula. Again, if you do have some less practice with the distance formula, it's really important for you to do advance that on that, because this is going to be really useful. So we need to use the distance formula. So if I take this point and I find the distance between these two, so I will get the x minus x, okay? And then whenever you get a little more chance, the difference between x doesn't change, so you don't really need to write this at all. So you can just skip this part, but for now I'm gonna write it. And the y value is y, and the y value is 5. So difference of the y's will be y minus 5 to the second power, and that will be under square root. So this is basically gonna give us the distance between this point and this point. And this has to be equal to distance between this to that point. So which is gonna be x minus -4, okay, and y minus 3. And then that's the second power, and that's under square root. Since we have square root on both sides, we can square both sides to get rid of those, and this is gonna be 0 squared, just 0. And that will give us y minus 5 to the second power is x minus -4 is just x plus 4 square, and y minus 3 to the second power. So sometimes it's kind of not obvious to find alone. So are we gonna get like x alone or y alone? So since the curve is just like upside down, or if you do like maybe upward, so those are gonna be the curve that we usually use, y equals some like expression in terms of x. So which means I like to get the x alone. Or the question will specifically ask you what to do. Maybe that will tell you what to do. But for now, I'm going to find the y alone. So if that's the case, I don't really need to expand this guy. Okay, I'm going to expand this guy. So y minus 5 squared. So I can really expand this by square of binomial. So that will be y squared minus 10y plus 25. And if you are struggling with this, just write y minus 5 twice and then multiply each other, okay? And equals x plus 4 to the second power. And then this guy will be same as this reasoning. So y squared minus 6y plus 9. So y squared and y squared will cancel. And then I'll add 6y to both sides. So that will be negative 4y. Okay, and then I will subtract 25 from both sides. So that should be x plus 4 to the second power. And that was 9 minus 25. Okay, so maybe I can divide by negative 4. So that should be y is equal to negative 1/4 x plus 4 to the second power. And this is negative 16, right? And then since we are dividing by negative 4, so that should be just plus 4. And that should be my final answer. So again, it does look like a bit complicated. So the goal is just to find the directrix of the parabola and the focus of the parabola, and then use the definition. Definition was any point on the curve will have the same distance from the focus as well as the line. Okay, so when we say the distance, we just mean the shortest path that you can actually go from any point on the curve to the line. Okay, in this case, that should look like this. Okay, and then as soon as you have the points, you just use the distance formula between those two, and then that will give us the equation of the curve, which is we call parabola. So I hope that makes sense, and we will do a little bit more practice, and this is the first one. So see you in the next videos.